In this video for section 8.3, we're going to find the terms of a geometric sequence. In the next video, we will find the value of an annuity. So what is a geometric sequence? A geometric sequence is a sequence where you are multiplying each term by a number to get the next term. That number that you multiply by is called the common ratio. So in arithmetic sequences, we are adding the same number each time to get the next term. In a geometric sequence, we are multiplying by the same number each time to get the next term. So we're going to write the first 5 terms of the geometric sequence with first term equals 20 and r equals 1/2. R is the common ratio, or the number that we are multiplying by. So our first term here is going to be 20. And 20 times 1/2 is going to give us the second term, which will be 10. 10 times 1/2 will give us the next term, which is 5. And for the fourth term, we're going to do 5 times 1/2 to get 5/2, or 2.5. Multiplying by 1/2 again will give us the fifth term, 5/4, or 1.25. Next, we're going to write the first 5 terms of this sequence. an equals -4 times an minus 1, and a1 equals 10. So this is a recursive formula. We have the first term, which is 10, and we have the formula which says, to get the term, you take the previous term and multiply by -4. So my first term is going to be 10. And for my second term, I'm going to do -4 times 10 to get -40. For my third term, I'm going to multiply by -4 again. That's going to give me positive 160. Multiply by -4 to get -640 for the fourth term. And finally, multiply by -4 one more time to get the fifth term. -640 times 4 is going to be positive 2,560. Next, we have a formula for the general form. So this would be an explicit formula where I can plug in the term number n and get the term that I want to find. So we're going to look at this sequence, 3, 12, 48, 192, and it's going to continue. First, we're going to identify our first term and our common ratio. Our first term is very easy to identify. The first number in the list is 3. R is the number that we are multiplying by each time to get the next term. So 3 times what equals 12? That would be 4. And then we multiply 12 by 4 to get 48. 48 times 4 to get 192. So next, we are going to write a formula for the general term of the sequence. So my formula is going to be a sub n equals the first term, which is 3, times 4 to the n minus 1 power. So 4 is my r is raised to the n minus 1. Now you have to be careful here because it's tempting to say, okay, well this is going to be 12 to the n minus 1 power. But that's not what it is because the 3 is not raised to the n minus 1 power. There's only one power of 3. There's multiple powers of r. So we cannot multiply these. Another way to think about it is that by order of operations, exponents has to come before multiply. So whatever n is, we would have to raise 4 to that power and then multiply by 3. So now we're going to find the 7th term of the sequence. So I'm going to plug in 7. So a sub 7 and that's going to be 3 times 4 to the 7 minus 1 power. So 3 times 4 to the 6th. I'm going to bring over my calculator here. So we're doing 3 times 4 to the 6th power. I get 12,288.